Okay, so question 7, part 2. So here we have to now find the coordinates of D. So in part I, we found the equation of CD, but in this question we're now asked to find the coordinates of D. So you just need to recognize in this question that D is the intersection between the line CD and the line AB. So once you know that, then all we need to do is get the equation of AB and get the equation of CD and solve those two equations simultaneously, because that's how we find points of intersection, because D in this case is the point of intersection between these two lines. So we already have the equation of CD, so all we actually need to get now is the equation of AB, and then we can find the points of D. So just keep in mind, in order to get the equation of a line, we always need the gradient of the line and any point that lies on the line. So x1, y1. So in this case, A and B lie on the line, so we can use either of these points as x1, y1. So let's get the gradient of AB. So the gradient of AB, so it's always change in y over change in x. So AB is 11 minus 3 over 13 minus 1. So we did this in the previous question, but just doing it again just in case. And this is going to be 2 over 3. So now that we have the gradient of AB, and we have points on the line of AB, we can now get the equation of AB. So the formula y minus y1 is equal to mx minus x1. We just need to sub this information into this formula or equation and then simplify to get the equation of AB. So we've got y minus y1. So y1, let's use a in this case as x1, y1. So y1 here will be 3. So y minus 3 is equal to our gradient, which is 2/3, times by x minus x1, which is just 1. And now we just get y by itself. So 2/3 times x is 2/3 x. 2/3 times minus 1 is minus 2/3. And then to remove the minus 3 from the left side, we have to add 3 on both sides. So we plus 3. So y is equal to 2/3 x, and then minus 2/3 plus 3 is positive 7 over 3. So now we have the equation of AB, and we have the equation of CD. We just need to solve these two equations simultaneously, and we'll get the point D. So I'm just going to scroll down. So CD, just to rewrite that here. So CD was y is equal to minus 3 over 2x plus 24. And we have AB, which is y is equal to 2/3 x plus 7 over 3. So we're going to solve these simultaneously. So in this case, we can just set these two equations equal to each other, because they both have y as the subject. So we're going to have minus 3 over 2x plus 24 is equal to 2/3 x plus 7 over 3. And now we just get x by itself. So I'm going to get all the x terms on the left side. So this is going to be minus 3 over 2x minus 2/3 x is equal to 7 over 3. And then get this 24 to the right side. We have to subtract 24 from both sides. So it's minus 24. So minus 3 over 2x minus 2/3 x is minus 13 over 6x. And 7 over 3 minus 24 is going to give us minus 65 over 3. And then to get x by itself, we divide both sides by minus 13 over 6. And that gives us an x of 10. And now we just need the y value of our D point. So we know this D coordinate has an x of 10. And because AB and CD meet at the same point, they'll have the same y value when x is 10, so we can sub the 10 into either equation of AB or CD. So you can choose which one is the easiest to do so. So in this case, we're just going to sub it into maybe CD. So CD's y is equal to minus 3 over 2x plus 24. So therefore y is equal to minus 3 over 2, and our x value is 10 plus 24. And this is going to give us a y of 9. So therefore D has the coordinate 10 and 9. So we'll probably just write that down here. So therefore D is 10 and 9. And we have answered the question.